Hello everyone, welcome back to my mathsmood. Today we have an interesting algebra problem. We need to solve this following equation in integers. We have 3 to the power m minus 2 to the power n equal to 1. How can we solve this? For this question we can solve it by finding all solutions and proving there are no others. So we have this equation. So first we observe that m and n are positive integers. Since 2 to the power n is greater than 0. And from here, if we plug in this, we will have 3 to the power m equal to 2 to the power n plus 1, which is greater than 0 as well, and moreover greater than 1. So from here, m is greater than 0 as well. So from here, m is greater than 0. So m is a positive integer, and 3 to the power m is positive integer as well. Is positive integer. So m is greater than 0 and 3 to the power m is positive integer. What are we going to do next? So 2 to the power m is n is equal to 3 to the power m minus 1. So I just write 2 to the power n from here. So we'll have 2 to the power n equal to 3 to the power m minus 1. So what we're going to do next? So this is an integer, then n has to be a non-negative integer. So a negative power of 2 is a proper fraction. Moreover, n is not equal to 0, because if n is equal to 0, then we will have that 3 to the power m equal to 2, which is impossible. So both m and n are positive integers. So what we're going to do next? Next we notice that m equal to n equal to 1 is a solution. So we notice that m equal to n equal to 1 is a solution. This is good, we find this solution. But take a look. Now let's assume that n is greater than 1. What we will have? This is if n equal to 0, not a solution. If n is equal to n and equal to 1 is a solution. This is good. Now let's assume that n is greater than 1. So what we'll have next? I write this right here. So if n is greater than 1, then we'll have that 2 to the power n is equal to 0 mod 4. So what does that mean? That means that 2 to the power n is congruent to 0 module 4. And what we're going to do next? Let's express from here this 3 to the power m equal to 2 to the power n plus 1. Just bring this 2 to the power m on the right. What we'll have? This will be equal to 1 module 4. So this is congruent to 1 module 4. So from here, m is equal to 2k. So m equal to 2k, where k is a positive. K is positive integer. So take a look what we will have. Now we will have the 2 to the power n equal to 3 to the power 2k minus 1. And it's a really good case because we will have a square minus b square. Let's factor in it. Factoring it we get 2 to the power n equal to 3 to the power k minus 1 and 3 to the power k plus 1. Because we can write this as 1 square and the formula difference of squares. Moreover, we can write this 3 to the power 2k as 3 to the power k square. So difference of squares. And take a look what we will have. So the integers 3 to the power k minus 1 and 3 to the power k plus 1 are both positive powers of 2. And they are 2 apart, so the only possibilities are 3 to the power k equal to 3 to the power k minus 1 equal to 2 and 3 to the power k plus 1 equal to 4. From here, as a result, we will have k equal to 1, and if we plug in all of these things, we will have that m equal to 2 and n equal to 3. So the solution to this, as you can see, we will have answer. We will have our answer. The first one if it will be m equal to n equal to 1. We find this right here. If m equal to n equal to 1, we have a correct equation. And the next pair we will have m equal to 2 and n equal to 3. So this is our pairs of solution. This is our answer. If you agree with this, if you disagree, maybe you have faster method how to solve it. It will be really interesting to read it. Thank you so much for watching, commenting. I really appreciate it that you're watching this algebra. It's really important for me. Write a question about this algebra problem if you understand it. If you don't, I'll be really excited to answer your question in a comment. Thank you so much for watching and see you in the next videos.